Welcome, ladies and gentlemen, to another episode of Dave Does Math from Home. Today we are working on section P4. This is about polynomials. And we're going to start with my favorite topic to discuss about polynomials, what the word means. There's a lot of confusion about what is a polynomial and what isn't a polynomial. A lot of that confusion is created by the name polynomial being kind of stupid and nonsensical. So we're going to look into that and we're going to figure out what a polynomial is. And then the rest of this section will be about adding, subtracting, and multiplying polynomials together. So if you look at this word polynomial, poly means many, nomial means number, approximately. You'd think that a polynomial is a number with many terms. And you would be completely wrong. This is a polynomial somehow. This technically is a polynomial. What the word actually means in practice in math is driven largely by calculus. And in calculus, when we get to calculus, we're going to start playing with different kinds of functions. We're going to play with exponential functions and logarithmic functions and trigonometric functions, lots of different flavors of functions, families of functions. The idea of a polynomial is basically like the basic function. So the things that go into defining polynomials are basically everything that could make doing calculus on a thing really, really easy and simple, no surprises, no weird nonsense going on. That's the basic idea behind a polynomial. But we're pretty far from calculus, so we're going to start off with how we can define a polynomial more simply. So, a polynomials have any number of terms. So, you could have a polynomial with many terms, and then the name makes sense. You could also have a polynomial with just one term, and then the name doesn't make sense, but we're doing our best. It has any number of terms, and the terms have any coefficient and whole number exponents. That's it. That's pretty much the whole thing. So you can have something like 5x squared minus 27x to the 8th plus pi x minus 137. This is a polynomial because it has a number of terms. 1, 2, 3, 4. It's got 4 terms. Each term can have a coefficient, 5, negative 27, pi, negative 137. Doesn't matter what the coefficients are. Coefficients can be anything. And the variable in each term has a whole number exponent. So here exponent is 2, here it's 8, here it's 1. Here you could say that it's technically 0, and that's fine. 0 as an exponent is okay on these guys. That works out. We don't usually call this the 0. Well, we call it a 0 degree term, but we usually don't write that there's an x to the 0 there. So this is a polynomial. It is sometimes easier to define polynomials by what they aren't. So this is a polynomial. That's happy. If you have something like 5x squared minus the square root of x, this is not a polynomial. Remember that square roots mean fractional exponents. So the square root of x means that it's an x to the 1/2. And now this is not a whole number exponent. So this is not a polynomial. And the reason for this, if we're going back to the calculus thing, The reason for this is that when you have fractional exponents, you get domain restrictions. So if you try to put a negative number in here for x, it's not going to work. And we really want polynomials to be like the basic starting point. This is well behaved, everything works, there's no problems, and square roots give us problems. So they are not allowed in the polynomial club. We don't want to deal with the domain restrictions there. That's no good. We could also do something like 4x squared minus 1 over x. This is not a polynomial because this 1 over x, that's the same as x to the negative 1. And this is not a whole number exponent, which is a problem for us because, again, domain restrictions. If we try to put 0 in here for x, we're going to have a big problem. And we want polynomials to not have any problems. We want them to not have any domain restrictions. So these guys are no good. No square roots, no division by exponents. Those count as square roots, count as fractional exponents, and that's not allowed. Division by division by variables counts as negative exponents, and that's not allowed. So none of that is allowed. Whole number exponents only. If you stick to whole number exponents, you'll never have any square roots, you'll never have any division, and so you'll never have any domain restrictions. You can plug any value for x imaginable, any real number you want, you can plug into this polynomial, or any polynomial, and it'll give you a nice, reasonable answer. So that's what a polynomial is. This is what polynomials aren't. This one is no good. That's no good. This one's good. And final note, this definition is very broad, and that's why things like x or 3, this is technically a polynomial. It's got one term, it's got a coefficient, whole number exponents, yeah, okay, whatever. 3 counts as a polynomial. It's the most boring polynomial in the world, but it is a polynomial. X is a polynomial. Doesn't make a ton of sense, but it's how it works. So, next step is we're going to talk about adding, subtracting, multiplying, and dividing these polynomials. The good news is that adding polynomials works exactly how you would expect it to work. You combine like terms, and then you just kind of put it together. There's only one x squared term. There's only one x term. The units term here, the 3 and the negative 4, those will combine into negative 1, and that's really all there is to it. Oh, 5x squared, sorry. There we go. This is all you got to do. Combine the like terms. If you have more interesting stuff going on, like 12x cubed minus 3x squared plus 4x minus 9, and you want to add that with 7x squared plus 7x plus 20. This is a polynomial. This is a polynomial. We can add these things together by combining like terms. There's only one cubic term, so that'll stay by itself. There's 2 squared terms. Negative 3 and 7 gives me 4. There's 2 x terms, so that'll be 11 of those. And the negative 9 and the 20 will give me an 11 there. So That's all you have to do to add them. I should pause here because there's a topic from the definition of polynomials that I forgot to cover, and that is degree. So let's talk about degree. The degree of a polynomial is the highest exponent. So this polynomial has degree 1. This polynomial has degree 2. Their sum has degree 2. This polynomial is a third degree. This one is a second degree, and their sum is third degree. There are other words for these. A 0th degree polynomial means that the highest exponent present is 0. So this is where you get things like 5. Technically. The name for this is constant. First degree polynomials could look like 7x minus 12. The name for this is linear. Hopefully you've seen, Hopefully you've seen linear polynomials before, things that look like this. Maybe you've seen them as functions. Those look like y equals mx plus b. So we're not doing the full equations with the y equals yet, but we have, this thing is still called a linear equation, or a linear polynomial. Second degree polynomials are things like x squared minus 8x plus 12. The name for this is quadratic, which I will yell about in a moment. Third degree polynomials look like 3x cubed minus 9x squared plus 15. And they don't have to have all these terms. Like this is missing its first degree term. Still a third degree polynomial. That's fine. They don't need to have everything present. This one is called cubic. Fourth degree polynomials might look like x to the fourth minus 81. Again, doesn't need to have all the in-between pieces. Doesn't even need to have the 81. It could just be an x to the fourth. That's a fourth degree polynomial. And at fourth degree, this is where they sort of stop having special names. You just call this one fourth degree polynomial. So here's me yelling about quadratics. There is a pattern to these names. It's just that the pattern is kind of stupid. Lines are one-dimensional. Cubes are three-dimensional. Squares are two-dimensional. Do you get it? It's a square. Quadrilaterals are squares. Do you get it? It's a square because this is x squared and this is a square and it's a quadrant. Do you get it? There's a lot of things about math that I just really hate. Like if I could figure out who named this thing and go back in time and punch them in the nose, I absolutely would. But that's the name now, so we just cope with it. These things are quadratic because they're squared. These things are cubic because there's cubes. These things are linear because they make straight lines. It makes a certain amount of sense if you squint and tilt your head a little. So we have polynomials, we have adding polynomials. I'm going to talk about subtracting polynomials really quick, and then I'm going to move to a second video so I can talk about multiplying polynomials. If you're subtracting two polynomials, something like x plus 15 minus 7x minus 3. The trick to subtracting is to never actually subtract anything. Subtraction is pretty much always a trap. It is designed to confuse and trick you, so don't do it. Instead of subtracting this, take this negative sign, distribute it in here, and make this into minus or plus negative 7x plus 3. So you flip the negative into subtraction, you distribute the negative into each of these pieces. 7x becomes negative 7x, negative 3 becomes positive 3, and then you just add them that way. You get negative 6x plus 18. That is my advice for subtracting things. Lots of students always try to just subtract it straight away. And subtracting this first piece always goes really well, and then by the time they get to the second piece, they've forgotten that they're subtracting something, and they're gonna do 15 and negative 3, and they're gonna try to tell me that that's 12. Don't do that. It takes no time at all to write this as another step with addition. Addition is easy. Just do addition. Distribute the negative sign and then add them. That's subtraction. I'm going to end this video. We got a nice 17-minute chunk of material here. I'm going to end this one at 17. I'm going to start part 2 of this section with multiplication. Stay tuned.